modulation. In modulation, what do? You multiply your signal with the carrier. That is the simplest of AM amplitude modulation, right? So see here, I am multiplying this pink noise with the carrier. Carrier is cos 2 pi FCT. What is the carrier frequency? 4000 hertz. Carrier frequency should be as high as possible, because only when the carrier frequency is very high, it can it can take the signal for a longer distance. Plot TTF command will plot both time domain and frequency domain in the same plot. That is the a unique feature of plot TTF. Usually we use only plot. So plot will plot the signal whatever you want. You have to specify the X versus Y, but in plot TTF, if you mention the signal comma the time domain, it will plot both the time varying graph as well as the frequency varying graph. And you see, this is going to be my spectrum, and the spectrum is going to be shifted by 4000. So this graph, this pink noise spectrum is shifted by 4000. So you add 0 plus 4000. At 4000, you have the signal. 0 minus 4000. At minus 4000, you have the signal. They again say there is nothing called negative frequency. So time is positive, so frequency is also positive. But why do we consider negative frequency? It is the property of symmetry. All transforms are symmetrical. So theoretically, you have what is called as minus f, but practically this minus f will not be visible to you. You have to take only the positive side of the frequency. So this is a simple example of an amplitude modulation where I have modulated my noise. The noise is at 0. The center of noise is at 0. Now the noise center is shifted to 4000 and minus 4000 because of modulation. So now in a DSP, we have seen how to modulate a simple noise signal. So in the place of noise, what will we do? You have to modulate a sine wave and you can check your answers. I'll be sharing all these boards so that it will be helpful for you at some point in your career. Okay. So instead of white noise, if you give A sine omega t here, you will get a beautifully modulated sine wave on both sides. Okay, that you can see it easily. So this example is the first we have started today. So we have seen how to record and play back the sound. I think the playback facility you are not able to hear. So in the recording the video which I will be sharing with you at the end of the day, please go to the particular time period and see whether the beep sound is heard by you. That is going to be the equivalent of your cos signal. Okay. So this is the first task we have done today. Now we'll go to the second one.